Welcome to A-Level Mechanics Year 1 Chapter 4. This is on variable acceleration. This is the last chapter in mechanics. Everything until now has always assumed there's been constant acceleration. Any change that do happen in acceleration are always sudden, like when a string breaks. In this chapter we have acceleration gradually change over a matter of time. So things we need to know is basic differentiation. So here if x equaled t squared minus 4t plus 7, to differentiate that it just goes to 2t minus 4. And then we want to find the value of t for when x is at a turning point. Whenever we see the phrase turning point or minimum or maximum, that means dx by dt equals 0. So therefore we're solving 2t minus 4 equals 0, and solving that gives us that t equals 2. Next we have the ways to define speed and acceleration. So if displacement distance is denoted by letter x, we denote speed by dx by dt. Again, it's basically the change in distance over the change in time. Acceleration we've seen as a change in speed over time, so that'll be the differential of this. And if you differentiate something twice, you just get a second differential. Okay, so a quick example question. Just use that notation. A particle P has this velocity. We know it starts in the origin. We want to know how far the big particle is next at rest. And we want to also know how far the particle will have travelled. So for a particle to be at rest, we're looking for velocity to equal 0. So we have 15 minus 2t equals 0. And solving that, t is going to be 15 over 2, which is the same as 7.5. We then want to work how far the particle will have travelled. So for that, we're going to use this formula. So we know v equals 15 minus 2t, and from what we just saw, we can also write velocity as dx by dt. We want to work out how far the particle has travelled, so we want to work out the value for x. We want to get x from dx by dt, we need to integrate. So again, that's just the opposite of differentiating. And if we integrate 15, that'll give us 15t. And if we integrate 2t, that will go to t squared. And again, you can check that if you differentiate this, it will then go back to this term here. When we integrate, we'll also have a plus c. Okay? We now need to work out how far it's travelled. We are told the particle starts at the origin. So this means at time t equals 0, my distance travelled is also 0. It's a really common cause. So when t is 0, x equals 0. If you plug that into this equation, you're going to get 0 equals 0 minus 0 plus c, which therefore means that c equals 0. So I've now got a slightly more concise formula, which is x equals 15t minus t squared. I'm now pretty much done. I want to work out how far the particle will have travelled. It's travelled 7.5 seconds. So I just plug in that value of t into here. So 15 times 7.5 minus 7.5 squared. And then you can just get your calculator and work that out. Which comes out being 56.25 metres. Okay, slightly more involved question. Here we've got the distance travelled particle given by this formula here. We're able to find the value of x when the turning points occur, there's more than one, and explain what each point represents, or the point if there's only one of them. So turning points, that means we're looking for dx by dt equals 0. So let's differentiate. We differentiate this, we're going to get 3t squared minus 6t minus 24, and the plus 4 is going to vanish, and we want to solve that equal to 0. Solving this, first things first, I can divide everything through by 3. So now I've got t squared minus 2t minus 8 equals 0. And this we can solve by factorising. This is going to be t minus 4, t plus 2 equals 0. Again, you can also solve by completing the square or using the formula. So I have two solutions. I have t equals 4 and I have t equals minus 2. Now for every single question, time can only go forwards. So that means you can never have a negative time. Time must always be positive, so we've only got one turning point. We then want to explain what this point represents. So if we know dx by dt equals 0, that means this point represents when the particle comes to rest. Or should I say instantaneous rest, because it's only at rest for one particular moment in time. Instantaneous rest. I would also go further than that and define it as a maximum or minimum, but I don't think it's overly relevant for this question. Okay, a slightly more involved question. Again, all the stuff you can see in exam questions as we're practicing all the different things they can throw at you. So, a car speeds off from traffic lights, and this is modelled in this form here. And we know it's only valid for the first 7 seconds. Okay, here S is displacement, before we used X, but S is fine. We then give us information. The instant when the car turns green, the light turns green, sorry, the car is 6 meters behind the traffic lights. We also know it passes the traffic lights after 2 seconds, and it reaches a top speed of 50 meters per second after a total of 7 seconds. We now want to find this equation, we want to find the values of A, B, and C. So we need to know what each basic information is telling us. So here, the instant the light turns green, so the second light turns green, we're assuming t equals 0. We know the car is 6 meters behind the traffic lights, so that means S equals minus 6. Again, if we're behind, we want a negative value for S. We can plug that in. So we've now got minus 6 will equal A plus B times 0 plus C times 0. So therefore A equals minus 6. We found out one of our 3 values. Next, we know that it passes traffic lights after 2 seconds. So that means when t equals 2, my displacement is 0. I'm at the traffic lights. So plugging that in, 0 is going to equal A, which is minus 6, plus 2t, because, not 2t, 2b, and here t is 2, so t squared is 4, so it's plus 4c. And next we're told it reaches a top speed of 15 meters per second after a total of 7 seconds. So we've got the speed here, which right now isn't useful because this is a displacement formula. However, we can go from displacement to speed just by differentiating. So if we differentiate this, ds by dt, that's going to be b plus 2ct. Again, feel free to check that in case that's not obvious. This here, that is going to be our speed or velocity. We're told it reaches a top speed of 15 meters per second after a total of 7 seconds. So 15 will equal b plus 2 times c times 7, so 7 seconds. So that's now 14c. So we haven't found b or c yet, but you should recognise both these equations are simultaneous equations. So let's write them next to each other, a bit more clear. So I've got b plus 14c equals 15, and here we have 2b plus 4c. If I take that minus 6 across, this now equals 6. Okay, we can now solve these. I can solve by elimination, so I'm going to double my top equation, which now gives me 2b plus 28c equals 30. If I now take away these two equations, 2b minus 2b is nothing, 28 minus 28 minus 4 is 24c, and 30 minus 6 is 24. So therefore c equals 1, and if I look at this equation here, you'll see quite straightforward. If c is 1, then b is also 1. So we have now worked out a, b and c. That's what we need to do. Okay, we could also write this down in proper form, which the actual formula was s equals minus 6 plus t squared. We weren't actually asked to, but say as a follow-on question, say it was asking when will we next be at rest or something, you might want to use that equation again. Okay, we've got one more type of example question that's worth looking at, and that's really this kind of layout. So a particle at this velocity, work out how far it travels over 10 seconds. What's unique about this is we have two separate velocities for different ranges of time. Okay, and typically for all of these, they're always going to overlap nicely. So if you plug t equals 3 into both of these, you get a velocity of 7. So they shouldn't suddenly jump velocity really quickly. That's kind of physically unrealistic. Okay, we're going to work out how far it travels over the 10 seconds. To do this, for this example, you could actually use SUVAT because vertical acceleration is constant, but that's not always true. So I'm going to use the more complete method and work it out by integrating. Again, we know velocity is the same as dx by dt. Distance of travel is just going to be x, so we can integrate to work it out. And I'm going to do it in 2 halves. So I want to work out x. I'm going to first integrate 2t plus 1, and that ranges from 0 to 3 seconds. And then I'm also going to integrate the other half from 3 to 10 seconds, which is 10 minus t. I'm going to work out both of these. So again, integration is like do reverse differentiation. So if we integrate this, 2t will go to t squared, and 1 integrates into t. And I have limits of 3 and 0. We're going to put both in a second. I can do the same here. Integrate 10 takes me to 10t. Integrate minus t will be minus t squared over 2. And my limits are 10 and 3. Now to work it out, we're going to plug in the top limit, take away the bottom limit. So plug in 3 first of all. So we've got 3 squared plus 3, and then minus plugging in 0, which is going to be 0 in this case. Same here, we first plug in 10. So we have 10 times 10 minus 10 squared over 2. And let's subtract from that the same thing when plugging 3 in. So it'll be 10 times 3 minus 3 squared over 2. Then all you need to do now is plug all this into your calculator. So this section here will just give me 3 squared plus 3, which is 12. This term here is going to be 100 minus 50, which is also 50, minus, this will be 30 take away 4.5, which is 25.5, and then we just add those all together, or let them take them away. And that will give us the total distance travelled. So again, all the calculus you learn in pure maths, a lot of it winds up coming back out to mechanics. So that means in total we travelled 36.5 metres here. Okay, and that's it. In terms of exams, they of course can give you harder things to integrate. Like it's possible to have squares here and cubes here. That doesn't change anything in terms of what you're doing. You're still integrating and follow the normal laws. Otherwise, that's pretty much it. I hope that made sense, and thanks for listening.